Hi, today we are going to learn how to classify more than 100 classes. Yes, more than 100 classes. Basically, we will classify 131 fruits and vegetables. For example, this eggplant can be classified, as you can see, as eggplant. So please join for this tutorial. You are most welcome to subscribe to my channel for more videos. So let's start with downloading the dataset. You can find it on Kaggle. Just look for fruits, and the first one is the fruit 360. So you can see examples of several classes, basically several fruits like apples, banana. Let's open one of these category and see the images. Let's try another one. So you can see for each of the classes, each of the fruits and vegetables, there are several images. So let's download and open the zip file and put it in our directory. I will copy it to a directory named dataset fruits 360. So after downloading and extracting the zip files, here are all the 131 categories. This is, for example, an avocado, and now it's one of the red apples. I believe it's understood. So let's start coding. First of all, let's create our first Python file. We will call it step number 1, build the model. And the first phase will be import some TensorFlow and Keras libraries. So we will import TensorFlow, and from Keras we will import some util functions like image to array that convert any image to a numpy array, and load image that has the ability to load image from the disk. And we will use NumPy and OpenCV. I didn't show it, but I believe that you know how to create a conda environment and install this type of Python libraries. Let's also import some Keras models functions. For example, we will use a CNN model, which is a sequential model, and some layers like conv to, MaxPooling, Dropout, flatten, and the dense, of course. You can also follow my other TensorFlow tutorials to see more examples and more projects of classify images. We will also import another important function called the image data generator that has the ability to import the images from the disk and do some data manipulation on the images. We will use early stopping that has the ability to follow our validation, and if it's not approved, we can stop the training and save our best model. So first of all, this is our train path. Don't forget the last slash, it's important, and our test path. Okay, let's put our test path as well. Now let's create a batch size variable. It will be 64. If you don't have enough memory, you can reduce it to 32, and it will also work with a 16 value as well. It will be slower, but if you have the ability, run it on 64 batch size. Let's load one of the images, and let's see the image that's just to double check that we can load it and present it. So I will choose a random image like this one. Let's copy the full path of the image. Okay, this is the image, and let's add the path As you can see, the full path is the train path plus our specific image path. And let's use the PLT or Pyplot Pyplot library. I can see that I haven't imported yet, so let's add it as well. Okay, let's show our image, and of course plt.show to display the window, and let's run it. As you can see, this is our image, so let's continue to the next phase. Now let's convert our image to NumPy array, and let's print the shape. It's important because our model need to know what kind of shape we are going to train. So as you can see, it's a 100 on 100 on 3 channels. This is the RGB, of course. And I can tell you that all the images are also in this shape, so it will be a very easy way to continue. We don't have to manipulate the images, so let's build our model. So it will be, of course, a sequential model, and the first layer will be a convolutional layer. Let's run it on 128 filters and a kernel size of 3, and of course activation of ReLU. The input chase will be 100 on 100 on 3 channels. Okay, the next layer. Okay, the next layer is a MaxPooling. I can see that I haven't chosen the right function. So let's fix it to MaxPooling 2D. So let's add a MaxPooling layer. Next, we will add another convolutional layer, and it will run on 64 filters. The same kernel of 3, and of course a ReLU activation function. As you understand, I already done several training, so I found that this is a very good model that you can try it yourself, and you may get a very good results. So as you can see, the next layer is a 32 convolution layer, then another MaxPooling. Now we will do a regulation based on dropout. Half of the neuron will be dropout. Then of course flattening the model, and now we will add several dense layers. First will be a 5,000 neuron, and the next one will be, we will reduce it to 1,000, and the last one will be our classification. So we will add another dense layer, and we will use 131 classes, and since it's a classification and more than one class, then we will use a softmax activation function. So let's print our model summary. As you can see, these are the layers, and the last one of course is the 131 classes. Now we will compile the model. The last function will be categorical, of course. We will use optimizer of SGD. I tried it with the Adam model as well, but I think that SGD got a better results, and the metrics will be accuracy. Now let's load our data from the folders. Okay, so let's create a train data generator. It will be based on image data generator that is basically a data augmentation function. So the images will be rescaled to between 0 and 1 by dividing it to 255, and we are going to augment the data using a vertical flip and zoom range. All these features help us to increase our data, increase our images. We are also going to create a test data generation, and the images are only going to be converted or rescaled to between 0 to 1. Then we are going to create our trained datasets. So we will use our previous trained data generation, and we will use the function flow from directory in order to retrieve the images from the trained path. So as you can see, we are passing several arguments, like the train path, where the images are being stored, the target size, which is 100 on 100, the batch size, that means that every 64 images will be a batch of images. It will be color images, and the class mode will be categorical. In this process, all the categories are being converted automatically to categorical labels. Next, we are going to do the same for the test dataset, and the difference is that we are going to use the test generator, and we don't need to shuffle or reshuffle the images. So now we have a train dataset and a test dataset that are named a train generator and test generator. Next, and before the training process, we are going to define what will be the steps per epochs. This will be by dividing the number of the trained dataset samples by our batch size. And we are going to do the same thing for the validation or for the test dataset. Okay, this is the validation steps, and now we continue for the next phase. Now we are going to create an early stopping. That means that we can set a very high value for the epochs, but during the training we are going to monitor the validation accuracy, and if the value of the validation accuracy will not be improved by a 5 epochs, that means that the training will be stopped, and then we will save the result as our best model. So now we are on the training process. We will pass several arguments for the fit function. The first, of course, is the trained dataset, then the number of steps per epoch. Next, how many epochs? Let's give a high value of 50 epochs. Then the validation data and the validation steps. And I believe it's done. And of course, sorry, the callbacks. The callbacks is relevant for the stop early argument. And after this training process, we will save the results of the model. We will save our model as fruit 360.h5. So this will be the full model with all the weights. And now let's run the model. Let's run all the code and see the training process. Okay, since the process is took about 2 hours, I run it here on a fast forward to go directly to the results. Okay, so let's run it. As you can see, I'm jumping directly to the last phase. So let's wait a few more seconds. Okay, this is epoch number 4. Okay, finished. As you can see, the validation accuracy is 0.9. That means it's very high one, and it took 23 epochs. And we save it here. So now let's see our model in our temp directory. Yes, this is the file. So now the last phase is testing the model with a fresh new image. I will leave the image and the code, of course, in my repository. And we will take an eggplant image and try to predict the label or predict the category of this image. So first of all, let's create a new Python program. We will call it test the model. We will import all the relevant Python libraries. We need, of course, TensorFlow and image to array and load image. And we will use NumPy and OpenCV as well. So first of all, let's load our model and print the summary of the model just to figure out that we load it correctly. Let's run it. It's loading the model. It will take a few seconds. As you can see, this is our model. We saw all the summary of the model, all the layers. So now let's load our categories. We have 131 categories. So we will import the name of the categories based on the test folders. So we will load all the names of the folders and then we will sort it. As you can see, we have 131 folders. So let's copy the name of the test folder, the full path. And next, let's load the list of the folders inside the test folder. We will use a simple function, a list here, and we'll send it the source folder. Let's sort all the categories and print it. Let's also calculate the length of the array. That means that we have to see 131 categories. Let's run it. As you can see, these are the categories and the number is 131. Good. Next, let's load an image that I have downloaded from Google. I will leave the image in my repo so you can use it as well. So let's first create a function that it will load the image, convert it to NumPy array, and prepare it for the prediction. So we are loading the image. We are targeting. We load it for a target size of 100 by 100. then we are converting the image to NumPy. And next we have to create an array that is based on a batch. That means that we have to add another dimension. So the image result will be based on the value of 1 and then a batch of images. So let's print the shape so it will be more clearly. So let's print the shape before the expand dims and after the expand dims. And of course the function will return as a result this NumPy array that contain a batch of images that contain only one image. So let's load our eggplant image. It will be clear in a few minutes. So first of all, we are defining the path for our eggplant image. And then we are running the function and sending as an argument the test image path. And then the outcome of this image result will be sent to our prediction function. We will use the argmax function to get the highest value, and we get the position of the highest value in the result, and let's print it. So let's run it. We have an error. Oh yes, of course, I didn't send the relevant argument. Let's run it again. As you can see, the category is 40. Now let's find the name of the category. That means what is a 40 position in our categories array. So let's print the category, the text of the category in position 40. Let's run it again. As you can see, the predicted image is eggplant. So now let's show the image, and we will put the predicted text on the image. So we will use the OpenCV. Let's read our image, and we will use the CV2 put text function in order to show the category of the image. Let's choose a random color. Let's show the image, and let's wait for a key to be pressed, and after the process is finished, we will destroy this window. Let's wait for the result. As you can see, this is an eggplant, and the text is shown in the upper left corner. Thank you very much. Hope you enjoyed this tutorial. Have a nice day. Bye bye.